In this video, we're going to talk about section 4.5 function operations. So in this lesson, students will be able to combine functions by addition, subtraction, multiplication, and a division, and identify the domain of the result. For the next lesson, we will be doing the rest of that objective. So I'm not going to go over that right now. So we're looking at function operations for this lesson. So the regular operations of addition, subtraction, multiplication, and division will be used with functions. So when I'm adding something together, I'm subtracting two functions, I can multiply two functions, I can divide two functions. We'll talk about this composition in the next lesson. So when I'm adding or subtracting or multiplying functions, I am taking and performing that operation with each function. So for the first problem, they're asking us to add, subtract, and subtract in two different ways, and then multiply two functions together. So they give us two different functions. They give us function f, which is 3x plus 4, and they give us function g, which is x squared minus 5x plus 2. And so in this expression, when they say f plus g, that means they want us to take and add f of x plus g of x. So when my functions are 3x plus 4, so I'm going to replace f of x with 3x plus 4. And then I'm going to add that with g of x, which is x squared minus 5x plus 2. And really the addition of functions is just combining like terms. So I'm going to just combine any like terms that I have to find my answer. So looking at this, I have a single x squared, so my answer is going to be x squared. And then I have a 3x minus 5x, so x squared minus 2x if I combine those together. And finally, 4 plus 2 plus 6. So the sum of f and g, or the expression f plus g, is x squared minus 2x plus 6. When I'm doing subtraction, so for this one, they're asking us to do f of x minus g of x. I'm subtracting the whole second equation. So I'm still taking f, which is 3x plus 4, but this time I'm subtracting the whole expression from g, which is again x squared minus 5x plus 2. Oops. So when I do this subtraction, what I'm doing is distributing the negative. So I need to make sure that I distribute the negative through that whole second expression. So it's going to become minus x squared plus 5x minus 2. But the 3x plus 4 is going to stay the same. So that 3x plus 4 wasn't being subtracted, so that expression signs stay as they were. And so when I combine like terms for this one, I now have a negative x squared, and then 3x plus 5x, so plus 8x, and 4 minus 2, so plus 2. So the difference of f minus g is negative x squared plus 8x plus 2. So that was adding f plus g, subtracting f minus g, and then for part C, they're asking us to subtract g minus f. And so that means that instead of taking g away from f, we're taking f away from g. And so we're changing the signs on the f of x equation rather than the g of x equation. So this time we're starting with g of x, which is our x squared minus 5x plus 2, and we're subtracting f, which is the equation 3x plus 4. So again, whenever I'm subtracting, I want to distribute the negative. Meaning I'm going to change the sign to minus 3x and minus 4 for all of f of x. And I'm just going to bring down x squared minus 5x plus 2 because g wasn't being subtracted. There was no negative in front. And so when I combine like terms, I've got a positive x squared. Then I have minus 5x minus 3x, so minus and 8x. And then plus 2 minus 4, so minus 2. So what you should notice is that our answer from part B was negative x squared plus 8x plus 2 when I was doing f minus g. And the only difference between g minus f is the signs, right? So this is exactly the opposite of f minus g. So when I calculate g minus f. And so that'll always happen. It's always where all the terms are the opposite because of what we're subtracting, what we're making negative for that different order. For D, we're multiplying f times g. So we want to do f of x times g of x, which means we're taking 3x minus 4 and multiplying that times x squared minus 5x plus 2. Just for the sake of organization, I'm going to do this one using the area model. So since I have a binomial times a trinomial, I'm going to organize this as a 2 by 3 box to use that area model to multiply. So I'm going to put 3x minus 4 on the vertical side and x squared minus 5x plus 2 on the horizontal side. And then remember to fill in the boxes. I'm going to multiply those two pieces together. So x squared times 3x is going to give us 3x to the third power. 3x times negative 5x is going to give us negative 15x squared. 2 times 3x is positive 6x. And then the second row, I'm going to multiply negative 4 times each term, so that's going to give us negative 4x squared. Negative 4 times negative 5x is going to give us positive 20x. And then negative 4 times 2 is going to give us negative 8. And so when I combine like terms to get my answer here, I have only this first x cubed, so I have a 3x cubed. And then notice that on each diagonal, I have like terms. So I have squared terms here, so I can combine negative 15 plus negative 4x squared is going to give us negative 19x squared. And then if I combine 6x and 20x, that's going to give us plus 26x. And then our last term is the constant minus 8. So the product of f times g is 3x cubed minus 19x squared plus 26x minus 8. So notice that when we did these problems, we did not do a different order for f plus g or for f times g. And if we think about that, that's because addition's commutative. So when I switch the order, I still would get the same answer, right? I'm still just combining like terms, nothing's changing. And same thing with multiplication. When I multiply this 3x minus 4 in front, it's not going to change the answer if I switch it to the back because multiplication, again, is commutative. So that's adding and subtracting and multiplying just in general within these problems for any given function. So adding, I'm really just combining like terms. Subtracting, I'm distributing a negative and then I'm combining like terms. And then multiplying, I'm multiplying the products together. functions together. For example 2, we are asked to apply some revenue problems. So the demand D in units sold for a company's new brand of cell phone at price X in dollars is demand of X equals 5,000 minus 10X. There's not supposed to be a minus there. So if we look at the equation here, sorry, those don't match. So 5,000 minus 10X is the equation for demand. So there was a typo in that part of the problem. And then what is the company's expected revenue from cell phone sales in terms of price? So we give you the formula for revenue. So revenue is the product of price times demand. So if we know their price is X, based on what we're given here. So their price is X, and then demand is 5,000 minus 10 times X. To find the revenue, we're going to multiply those two things together. So the revenue is equal to the price function, which is just X, times the demand function, which is 5,000 minus 10X. And so if we multiply this, really this is just a distribution problem. So we need to distribute the X to both pieces. Then the revenue in relation to the price is 5,000 X minus 10X squared. Okay, so that question was just asking us to find revenue by multiplying the price function times the demand function. So for all of those functions that we were talking about, there was no domain restriction because we had a polynomial expression as our result. So we were adding polynomials, subtracting polynomials, multiplying polynomials, and those operations are closed under those functions, meaning that every time I multiply, subtract, add polynomials together, my result is still a polynomial. And polynomials have infinite domains, so all real numbers work inside of them. When I'm dividing polynomials, however, that creates a rational function. So remember that rational functions have restrictions on their domains. So we have all real numbers except for specific values that will make the denominator 0. And so what we're doing for these problems is when I'm doing this polynomial division, it's really like simplifying a rational function. So if I have f of g, so f divided by g, they want us to evaluate f of x over g of x. And so in order to do that, what we're going to do is actually factor each of them. So if f of x is x minus 7, and g of x is 2x squared minus 13x minus 7, then what I want to do is to see if I can reduce this and identify any values that will make my denominator 0. Since my denominator is a quadratic, I want to try to factor that. And so what we're going to do here is factor g of x using a product sum. So since g of x is a quadratic where a is 2, we're going to multiply 2 times negative 7 and get negative 14. So we want two numbers that multiply to negative 14 and add to negative 13. So those two numbers are going to be negative 14 and positive 1. So negative 14 times positive 1 makes negative 14, and then negative 14 plus 1 makes negative 13. So remember that because a is not 1, this is where we have to do grouping. So we're going to have to take our 2x squared and our negative 7 from the original problem and use the negative 14 and the 1 to split up our negative 13x. And so when I'm doing this factorization, I have to factor out a GCF from each part of the two groups that I create. So 2x squared minus 14x, those two terms have a greatest common factor of 2x. So we want to take a 2x and factor that out of the two terms. When we divide 2x squared by 2x, we're left with x. And when we divide negative 14x by 2x, we're left with negative 7. So our first set is 2x times x minus 7. Remember what this means is that we should also end up with an x minus 7 left over when we find the GCF of the second half of the second group. And so since it is x minus 7, that means that the GCF for this is just 1. Remember that we have to write the 1 when we're factoring by grouping because the next step is to factor out the new greatest common factor of these two terms. So the 2x times x minus 7 and the 1 times x minus 7 we think of as terms, and they share the x minus 7. So that means x minus 7 is one of the factors of 2x squared minus 13x minus 7. The other factor is 2x plus 1. And so remember that the 2x is what's left over when I factor out the x minus 7 there, and the plus 1 is what's left over when I factor out the x minus 7 there. So what we've done now is we've simplified our denominator to be x minus 7 times 2x plus 1, while our numerator is already x minus 7, so we can't factor that or do anything of that nature. So if we think about this, this reduces. So the x minus 7 reduces, which means that we are left with 1 over 2x plus 1 as our answer. Okay, so the simplified version of f over g is 1 over 2x plus 1. So remember that when we're looking at the domain of this function, we're looking at all values for which the denominator is 0. So we know that each factor creates a restriction on the domain. So what we have to do in order to identify the domain is we know it's all real numbers except any values that will make the denominator 0. So our denominator was x minus 7, so that's not allowed to be 0, which means that x is not allowed to be 7. So it can't be 7. Our other piece of our denominator is the 2x plus 1. If we say that that's not allowed to be 0, that means 2x is not allowed to be negative 1. And so if we divide by 2, that means that x is also not allowed to be negative 1/2. So remember that our domain of f over g is the set of all values for which f, g, and f over g are defined. So what happens here is that g can't be equal to 0. So the only two times that g will be 0 is if x is 7, because that makes x minus 7 0, or if x is negative 1/2, because that makes 2 x plus 1 1/2. So this common error over here is saying to not forget about what you reduced. So since we reduced this, the 7, that you can't forget about it when you're finding the domain. Okay, so before simplifying. So what we're gonna do for the rest of these is just kind of practice for good measure. So we'll see different kind of factoring techniques and just practice in that way, but the setup is all the same. So for part B, we have f over g And so we're going to write f of x divided by g of x. And so in this problem, f of x is x squared minus 3x minus 18. And g of x is x plus 3. So that's going to be over x plus 3. And so since our quadratic is one where a is 1, that means this is a quick factoring where once we find our pattern numbers, those are just parts of the factors. So if we do the product sum with x squared minus 3x minus 18, we're looking for two numbers that multiply to negative 18 and then add to negative 3. So those two numbers are going to be negative 6 and positive 3. So negative 6 plus 3 also makes negative 3. So that means that our numerator factors to x minus 6 times x plus 3 over the x plus 3 over the x plus 3 that was g of x. And so notice that this time now our x plus 3 cancels, so there's nothing left in the denominator, so our answer is just going to be x minus 6. And our domain, since we canceled out the only piece of our denominator, remember that we know that x plus 3 is not allowed to be 0. So that means that x is not allowed to be negative 3. So our domain for this is all real numbers just except negative 3, because there was only one value in the denominator, one expression in the denominator. So for our last problem, we've got g over f. And so we're doing the exact same thing again, simplifying and finding the rule. And so for this one, if I take g, which is x minus 3, so I'm going to take x minus 3, whoops, I was just going to write x minus 3, and divide that by f, which is x squared minus x minus 6, then I want to try to factor anything. So x minus 3 is linear. I'm not going to be able to factor that. But x squared minus x minus 6 is quadratic, and it's the nice quadratic where a is 1. And so if I am looking for numbers that multiply to negative 6, and they add to negative 1. And so those two numbers that multiply to negative 6 and add to negative 1 will be negative 3 and positive 2. So that means that we end up with x minus 3 over x minus 3 times x plus 2. And so the x minus 3 will reduce with the x minus 3. And so we're left with 1 over x plus 2 as our answer. And then for our domain, remember, we need to still account for anything that was originally in the denominator. And so our domain is going to be all real numbers except two values. The x minus 3, not allowed to be 0, tells us that x is not allowed to be positive 3. And the x plus 2 not being allowed to be equal to 0 is going to tell us that x is not allowed to be negative 2. So our domain then is all real numbers except positive 3 and negative 2. So the problems that go along with this assignment are on page 208. They're numbers 5 through 10, and then 20 to 23. We'll have those printed so that you can look at them within your table groups and work on those for the rest of class.